The infantry problem had existed since 1914. Men crossed open ground. Machine guns fired. Men died. For 30 years, armies had tried to solve it with doctrine, with training, with courage. None of it worked. The killing happened faster than men could move. The mathematics were brutal and consistent. A machine gun could fire 500 rounds per minute. A rifleman could run perhaps 200 meters in a minute if the ground was good and he wasn't carrying equipment. He was carrying equipment. The ground was never good. The machine gun always won. Armies had tried everything. They tried advancing at night. The Germans used flares and pre-registered fire zones. They tried smoke screens. The wind shifted or the smoke cleared and men died in the gaps. They tried massed artillery preparation. The shells would stop and the defenders would emerge from bunkers and dugouts before the infantry could close the distance. Every solution created new problems. The fundamental equation remained unchanged. By June 1944, the Allies had landed in Normandy with overwhelming firepower. They had air superiority. They had tanks. They had artillery that could flatten entire villages. The industrial capacity of America and Britain had produced weapons in quantities the Germans couldn't match. But when infantry needed to take ground, they still had to walk. And walking meant dying. The Normandy bocage made it worse. The hedgerows of northern France were ancient field boundaries, thick earthen walls topped with dense vegetation. They turned the countryside into a maze of small enclosed fields. Visibility was measured in meters. Each field was a potential killing ground. Each hedgerow could hide defenders. The terrain that had been farmland for centuries became a defender's paradise. Tank crews found themselves nearly blind. The narrow lanes between hedgerows restricted movement. The thick vegetation concealed anti-tank guns until they fired. Tanks that tried to cross the hedgerows exposed their thin belly armour. The bocage neutralised much of the Allied advantage in armour. It forced the war down to the level of small units fighting for individual fields. Infantry fought this warfield by field, hedgerow by hedgerow. A company would attack across 100 meters of pasture to reach the next hedgerow. German machine guns and mortars would open fire from the opposite side. Men would go down. The survivors would reach cover, reorganize, and prepare to attack the next field. Progress was measured in hundreds of meters per day, sometimes less. The casualty reports told the story. Battalions that landed in Normandy at full strength were at half strength within weeks. Replacement drafts arrived and were fed into the fighting. They became casualties before learning the names of their squad mates. Unit cohesion, the invisible bond that held combat units together, eroded under the constant grinding losses. The Germans understood this. Their defensive doctrine relied on it. Machine gun nests were positioned to create overlapping fields of fire. Mortars were pre-registered on likely approach routes. Snipers waited in rubble. The German army had been retreating for a year across the Eastern Front, but they knew how to make every meter cost blood. In Normandy, they had terrain that multiplied their effectiveness. German defensive manuals from the period show the calculation. A machine gun team in a prepared position could stop an infantry platoon. The attackers would need artillery support, flanking maneuvers, and probably a casualty rate of 30% to dislodge a single gun. The Germans didn't need to win every engagement. They just needed to make victory expensive enough that the Allies bled out before reaching Germany. Allied commanders watched their battalions bleed crossing fields that tanks had already passed through. The armour would punch a hole in the line, then pull back. The tanks couldn't occupy ground. They needed fuel and ammunition. They needed to avoid being cut off. So they would withdraw to defensive positions and wait for infantry to consolidate the gains. The infantry would follow on foot, exposed, and the Germans would return to their positions. Machine guns that had stayed silent when the tanks passed would open fire on the walking men. Mortars would begin dropping rounds on the approaches. The pattern repeated itself across France. Advances were measured in hundreds of meters. Casualty reports grew longer. The planning staffs knew the numbers, An infantry company attacking across open ground could expect 30% casualties before reaching the objective, sometimes more. In particularly strong defensive positions, the number could reach 50%. The math was simple and terrible. Every attack meant choosing which men would probably die. Officers writing attack orders understood what the plans meant. They would designate assault companies, support companies, reserve companies. They would establish objectives and phase lines. They would coordinate artillery and air support, and they would know, with statistical certainty, that a specific number of the men receiving those orders would be dead by nightfall. The number could be reduced with good tactics and good luck, but it couldn't be eliminated. Tank commanders saw it too. They would break through German positions, then watch from their steel boxes as infantry struggled forward through the same ground, unprotected. The tanks had speed and armour. The infantry had neither. The two forces operated in different worlds, even when fighting the same battle. The division between armour and infantry was doctrinal. Tanks were breakthrough weapons. They would concentrate at a weak point, smash through the defensive line, and exploit into the rear areas. Infantry would hold the shoulders of the breakthrough and consolidate the captured ground. The two branches trained separately, fought separately, and planned separately. They coordinated, but they didn't integrate. This division made sense in theory. Tanks needed speed and freedom of movement. Infantry needed time to dig in and establish defensive positions. Combining them would slow the tanks without protecting the infantry. The doctrine had been developed over years of study and experience. It seemed sound. But doctrine was written for ideal terrain and theoretical battles. Normandy was neither ideal nor theoretical. The bocage prevented the sweeping tank advances that doctrine envisioned. The German defensive positions were too numerous and too well concealed for artillery to eliminate them all. The gap between what was supposed to happen and what actually happened was filled with casualties. Canadian forces faced this problem near Caen in July. The city had become a grinding battle of attrition. Montgomery had intended to take Caen on the first day of the invasion. It was now week 6, and the city was still contested. German defences were layered deep. Panzer divisions that should have been counter-attacking the beaches were instead dug in around Caen, using the rubble and the terrain to maximum advantage. Every attack required infantry to cross ground that had been fought over, shelled, and fortified. The approaches to Caen were known to German artillery observers. Machine gun positions had been refined through weeks of combat. Mines had been laid, wire had been strung. The casualty rates were unsustainable. The Canadian 2nd Armoured Brigade had been fighting in this sector since the landing. They had taken losses. They had seen infantry units they supported suffer worse. Tank crews would watch infantry advance toward objectives, watch men go down under machine gun fire, watch the survivors go to ground and call for support that couldn't help them. The frustration was intense. Someone made a decision. The records don't clearly show who. It might have been Lieutenant Colonel Gordon Churchill of the 1st Canadian Armoured Personnel Carrier Regiment. It might have been a battalion commander whose name didn't make it into the official histories. It might have been someone who simply got tired of writing letters to families. But someone looked at the tanks returning from battle and asked a different question. The question was simple. If tanks could cross ground that killed infantry, why weren't infantry crossing that ground in tanks? The answer was equally simple. Tanks weren't built to carry infantry. They were fighting vehicles with specialized crews. But that answer assumed the tanks had to keep fighting while carrying infantry. What if they didn't? What if a tank just became a transport? The Sherman tank was not designed to carry infantry. It was a fighting vehicle with a crew of 5. The driver sat in the front hull. The bow gunner sat beside him. The commander, gunner, and loader worked in the turret. The engine was in the back. The ammunition was stored in various racks and bins. There was no passenger compartment. There were no doors. There was no vision for anyone not in a crew position. It was a terrible troopship, but it was available. And it had armour. The modification was crude. Gun turrets were removed. The process took several hours and required a crane or hoist. Some of the ammunition was offloaded to create space and reduce weight. The internal racks were pulled out or pushed aside. Space was cleared inside the hull where the turret basket had been. Infantry squads were told to climb in through the top hatches. 8 to 10 men squeezed into a space designed for 5. It was cramped. Soldiers sat on the floor, on ammunition boxes, on anything that provided a surface. It was dark. The only light came from the hatches and the driver's vision blocks. Ventilation was poor. The engine heat was overwhelming. In summer, the interior temperature could exceed 40 degrees Celsius. Movement was impossible. Once men were inside, they stayed inside. There was no room to shift position. Taller soldiers had to hunch. Equipment dug into ribs and backs. The engine noise made communication nearly impossible. Diesel fumes seeped into the crew compartment. Men got sick. Everyone was uncomfortable. No one cared. Because the armor worked. The first test came during an attack on a fortified village south of Caen. The exact date is disputed in various accounts, but it occurred in late July during Operation Atlantic. The modified Shermans moved forward with regular tanks. The column advanced across open farmland toward German positions. German observers saw the tanks coming. They reported the advance. Machine gun crews took position. Mortar teams prepared fire missions. Anti-tank guns tracked the lead vehicles. The defenders were ready. This was exactly the kind of attack they had stopped dozens of times before. The tanks kept coming. Machine gun fire started at 800 meters. Rounds sparked off armor plate. The tanks didn't slow. At 400 meters, mortars began dropping. Explosions bracketed the vehicles. Still they advanced. At 200 meters, anti-tank guns engaged the lead Shermans. One brewed up. The crew bailed out. The others kept moving. The tanks reached the village. They pushed past the first buildings. They entered the main square. Then they stopped. Hatches opened. Infantry poured out. The German defenders had prepared for infantry advancing across open ground. They had not prepared for infantry arriving inside armor. The timing was wrong. The positioning was wrong. Machine gun nests that should have stopped the attack were suddenly dealing with troops emerging from behind them, beside them, on top of them. Defensive plans that had worked for 30 years stopped working. The machine gun team positioned to fire across the approaches found infantry attacking from their flank. The mortar team registered on the field edges found themselves under small arms fire from inside the village. The carefully constructed defensive positions were compromised before they could be fully employed. The infantry that emerged from the Shermans were still fresh. They hadn't spent 20 minutes crossing open ground under fire. They hadn't taken casualties on the approach. They hadn't been suppressed and pinned down. They were ready to fight immediately. They had arrived at the objective with their squad integrity intact, their ammunition full, and their organization preserved. The village fell in 90 minutes. Normal casualty rates for such an attack would have been 30 to 40%. The actual casualties were less than 10%. Most of those occurred after the infantry dismounted. The approach, the part that usually killed the most men, had cost almost nothing. Word spread quickly through Canadian units. Soldiers talked. Officers compared notes. Battalion commanders asked questions. More tanks were converted. More turrets came off. More infantry started riding inside instead of walking behind. The vehicles got a name: kangaroos. The origin of the name is unclear. Some accounts say it came from the pouch-like appearance of men emerging from the hatches. Others say it was because the vehicles hopped from position to position. Another story claims it was an Australian officer's joke about carrying things in pouches. The name stuck because someone thought they looked odd and because soldiers will nickname anything that keeps them alive. The conversion process became standardized. Priest self-propelled guns had their artillery removed. The Priest was based on an American tank chassis, but carried a 105mm howitzer in an open-topped fighting compartment. Remove the gun, and the compartment could hold a full infantry squad with reasonable comfort. The vehicle had been rendered obsolete by newer, self-propelled guns. Hundreds were sitting in depots. They became kangaroos. Ram tanks were converted. The Ram was a Canadian design that had been superseded by the Sherman. As a gun tank, it was obsolete. As an armoured carrier, it was adequate. The turret came off. Infantry climbed in. The vehicle found a new purpose. Anything with armor and an engine was considered. Even damaged tanks that couldn't be repaired to fighting condition were evaluated for conversion. Vehicles that would have been scrapped became troop carriers. The goal was simple: get infantry to the fight without losing them on the way. Production was improvised but effective. Engineer units set up conversion facilities near the front lines. A steady stream of tanks and self-propelled guns arrived. Turrets were removed. Interiors were modified. Armored carriers rolled out. The process took days, not weeks. No one waited for perfect engineering. Good enough kept men alive. Other Allied forces noticed. British units began requesting similar conversions. American commanders started experimenting with the concept. Within weeks, the improvisation had spread across multiple armies. It hadn't come from a manual. It hadn't been tested at a school. It had emerged from necessity and proven itself in combat. The tactical implications were immediate. Infantry could now keep pace with armor during the initial breakthrough. Tank attacks had always faced a problem. The tanks would advance faster than the infantry could follow. The breakthrough would be exploited for a few kilometers. Then the tanks would have to stop and wait for infantry to catch up. That gap gave defenders time to reposition and establish new lines. With armored carriers, the gap disappeared. Infantry arrived with the tanks. Breakthroughs could be exploited immediately. Ground could be held as soon as it was taken. The tempo of operations increased because the supporting elements moved at the same speed as the spearhead. Infantry could attack from unexpected directions because they weren't limited to routes that offered cover. Traditional infantry tactics required using terrain for concealment and protection. Advanced routes followed tree lines, stream beds, any feature that would mask movement from enemy observation. This made attacks predictable. Defenders could anticipate approach routes and prepare accordingly. Armored infantry wasn't bound by these limitations. The carriers could cross open ground that would be suicidal for walking infantry. Attack routes that seemed impossible became viable. Defenses prepared for predictable approaches were hit from unexpected angles. The tactical flexibility fundamentally changed how attacks were planned. The relationship between tanks and infantry shifted. They were no longer separate forces coordinating movements. They were a combined system. Tank officers and infantry officers began planning together from the start. Radio procedures were developed for communication between carriers and gun tanks. Formations were adjusted to integrate both types of vehicles. The improvisation was becoming doctrine, though no one had written the manual yet. German after-action reports began noting the change. Defensive positions that should have held were being overrun. Infantry was arriving in strength at points that should have been unreachable. The calculations that had governed defensive planning were no longer reliable. Machine guns that could stop men on foot couldn't stop men in steel boxes. A German company commander near Falaise wrote that defending against armored infantry required different tactics. Machine guns needed to be repositioned to engage dismounting troops rather than approaching formations. Mortars needed to be ready to fire immediately at close range rather than at distant approach routes. Anti-tank weapons became necessary even in positions designed purely for anti-infantry defense. The entire defensive system needed adjustment. The Germans had some experience with mechanized infantry. Their Panzer Grenadier units rode in half-tracks. But German half-track production was limited, and fuel shortages meant many Panzer Grenadier units walked like regular infantry. The half-tracks that did exist were concentrated in elite formations. The average German infantry division had none. More importantly, the German half-track was lightly armored. It would stop small arms fire and shell fragments, but heavy machine gun fire could penetrate it. The vehicle was useful for movement under normal conditions, but couldn't survive concentrated defensive fire the way a tank hull could. German doctrine recognized this. Panzer Grenadiers dismounted well before reaching defensive positions and advanced on foot for the final approach. Allied armored carriers went all the way to the objective. The armor was thick enough to ignore machine gun fire completely. Only anti-tank weapons or large-caliber guns could stop them. This meant defenders needed heavier weapons in positions that previously only faced infantry. The defensive calculations changed. Positions that could be held with machine guns and mortars now needed anti-tank guns. Ammunition requirements increased. Defensive depth became more critical. The Battle of the Falaise Pocket in August showed the concept at scale. Canadian and Polish forces used armoured infantry carriers extensively during the encirclement. The operation required rapid advances over varied terrain to close the pocket before German forces could escape. Speed was essential. Casualties had to be minimized to maintain momentum. The armoured carriers made it possible. Infantry units moved as fast as the tank columns. They could exploit breakthroughs immediately. When German units attempted to break out, they encountered infantry that had arrived faster and in greater strength than defensive doctrine predicted. The pocket closed. Thousands of German soldiers surrendered. The tactical advantage of armoured infantry contributed directly to the operational success. The casualty rates changed. Infantry units using armoured carriers took significantly fewer losses during approach phases. The most dangerous part of the attack, the walk across open ground, had been eliminated. Men still died. War remained war. Artillery still fell. Mines still exploded. Ambushes still happened. But they died fighting at the objective, not dying on the way to it. Battalion commanders could see the difference in their morning reports. A company attacking with armoured carriers would report 10 casualties, where the same attack a month earlier would have cost 40. The mathematics of attrition shifted. Units could sustain combat operations longer. The replacement system could keep up with losses. Cohesion improved because men survived long enough to become experienced. Morale improved. Infantry soldiers knew the carriers made them safer. The psychological impact of crossing open ground under fire was eliminated. Men still feared combat, but they didn't have to fear the approach march. The knowledge that they would arrive at the fight rather than die before reaching it changed how soldiers thought about operations. Junior officers noticed they could plan more aggressive operations. Previously, attacking certain positions would cost more casualties than could be justified. The position might fall, but the attacking unit would be combat ineffective afterward. With armoured carriers, those positions became viable targets. The tactical options expanded. Commanders had more flexibility. After Normandy, the concept spread. British forces developed the Kangaroo into a formal vehicle type. The British 79th Armoured Division, which specialised in unusual armoured vehicles, took over development and production. They standardised the conversion process. They developed training programs. They wrote tactical manuals. The improvisation became institutionalised. American forces began designing purpose-built armoured personnel carriers. The American approach was typically more ambitious. Rather than converting existing vehicles, they wanted a new design optimized for the role. The development process was slow. The war ended before American armored personnel carriers saw significant combat. But the doctrinal commitment was made. Soviet forces, already experimenting with infantry riding tanks, expanded the practice. Soviet tank riders had been common on the Eastern Front since 1942. Infantry would literally ride on the outside of tanks, clinging to handholds welded to the hull. It was dangerous. Men fell off. Machine gun fire swept them away, but it was faster than walking and offered some protection from small arms. The Soviets saw the Western Allied armoured carriers and recognized a better solution. They began developing their own designs. The BTR series of armoured personnel carriers emerged from this recognition. Soviet doctrine evolved to incorporate mechanized infantry as a standard element of tank armies. The Red Army became the most thoroughly mechanized force in the world. The post-war armies all adopted the concept. The American M113, introduced in 1960, became one of the most produced armored vehicles in history. Over 80,000 were built. It served in Vietnam, in the Middle East, in dozens of conflicts. The design was simple and functional, a direct descendant of the improvised Kangaroos. The Soviet BMP, introduced in 1966, took the concept further. It wasn't just an armored transport. It was an infantry fighting vehicle with a cannon and anti-tank missiles. Infantry could fight from inside or dismount to assault. The vehicle was designed from the start as an integrated system where infantry and armour worked as one. The British Warrior, the German Marder, the French AMX-10P all shared the same fundamental concept. Infantry needed to move under armour. The specific vehicles changed. The engineering improved. Climate control was added. NBC protection became standard. Fire control systems were integrated, but the core idea remained. Don't make soldiers walk through machine gun fire if you can drive them through it instead. Modern mechanized infantry operates on principles established in the summer of 1944. Infantry fighting vehicles combine transport with fire support. Squads dismount near objectives rather than far from them. The integration of armour and infantry isn't an option, it's the foundation of how armies operate. Current American doctrine divides infantry into light, airborne, air assault, and mechanized. Only the mechanized infantry is considered suitable for high-intensity conventional warfare. The others have specialized roles, but when facing a peer military, the expectation is that infantry will fight from vehicles. The lesson from Normandy became permanent. The entire structure of ground combat was reshaped by a decision made when someone looked at a tank and saw a bus. Division organization changed to accommodate mechanized infantry battalions. Training changed to teach mounted and dismounted tactics. Logistics changed to support vehicles that consumed fuel and parts. The ripple effects touched every aspect of ground warfare. The impact shows in what didn't happen. Thousands of soldiers who would have been casualties crossing open ground survived because they crossed it inside steel. They went home after the war. They had families. They had lives that wouldn't have existed if the old tactics had continued. The numbers are impossible to calculate precisely, but the effect was real. Consider a single infantry company in Normandy, 200 men. In a month of combat using traditional tactics, that company might take 60 casualties. With armoured carriers, perhaps 20. The difference is 40 men. 40 men who lived instead of dying. 40 men who had futures. Multiply that across divisions, across armies, across campaigns, and the scale becomes apparent. The change also appeared in how attacks were planned. Commanders could consider operations that would have been suicidal with walking infantry. Rapid advances became possible. Exploitation of breakthroughs became practical. The tempo of operations increased because infantry could keep up with armour. Wars moved faster because men didn't have to walk through fire. The 1944 pursuit across France demonstrated this. After breaking out of Normandy, Allied forces advanced hundreds of kilometres in weeks. Infantry and armoured carriers could maintain the pace. They could keep up with tank spearheads. They could secure objectives while armour pushed forward. The speed of the advance was unprecedented for sustained operations. Compare this to World War I. Advances were measured in kilometres per month. Infantry couldn't move faster because they had to walk. Tanks existed by 1918, but infantry couldn't keep up with them. The breakthrough at Amiens in August 1918 advanced 15 kilometres on the first day, then slowed as infantry struggled to consolidate gains. In 1944, infantry and carriers could maintain operational tempo for days. The Germans never fully adapted. They had developed half-tracks for mechanized infantry, but fuel shortages and production priorities meant most German infantry still walked. Late in the war, they faced Allied forces that moved under armour while they remained exposed. The tactical disadvantage compounded their strategic problems. A German infantry division in 1944 might have a few dozen half-tracks for reconnaissance or headquarters units. The infantry battalions marched. They moved at walking speed. They were vulnerable to air attack. They couldn't match the pace of Allied advances. When attacked, they couldn't concentrate quickly enough to respond. The mobility gap became a combat multiplier for the Allies. This mattered in the final campaigns. The crossing of the Rhine, the advance into Germany, the encirclement of the Ruhr, all relied on rapid movement by mechanized forces. German infantry divisions couldn't reposition fast enough to counter these moves. They were bypassed, cut off, and forced to surrender. The mobility advantage was decisive. The Germans attempted some countermeasures. They concentrated anti-tank weapons in defensive positions. They used Panzerfausts, which infantry could carry, to engage armored carriers. They tried to develop ambush tactics that would force Allied infantry to dismount early. Some of these tactics worked in specific situations. None of them solved the fundamental problem that German infantry walked while Allied infantry rode. By 1945, the concept was no longer improvisation. It was standard practice. Field manuals were updated. The US Army published FM 1742 Armored Infantry Battalion in late 1944. The manual codified lessons learned in combat. It established procedures for mounted and dismounted operations. It became the foundation for mechanized infantry doctrine. Training programs were established. New units were taught armored infantry tactics from the start. Soldiers learned to fight from vehicles. They practiced mounting and dismounting under fire. They coordinated with tank units in combined exercises. The institutional knowledge was captured and transmitted. New vehicles were designed from the start as infantry carriers. The lessons learned from the improvised kangaroos informed engineering requirements. Purpose-built carriers needed certain characteristics: enough armor to stop machine gun fire, enough speed to keep up with tanks, enough capacity to carry a squad, and enough reliability to operate in sustained combat. The engineering challenges were significant. Armor meant weight. Weight meant more powerful engines. More power meant more fuel consumption. Fuel consumption meant larger fuel tanks or shorter range. Balancing these requirements took years. The early post-war designs were compromises, but they were informed compromises, based on combat experience rather than theoretical assumptions. The lesson traveled beyond World War II. Every major conflict since has involved armored infantry carriers. Korea saw American forces using half-tracks and experimenting with early armored personnel carriers. The terrain limited their effectiveness, but they were present. Vietnam saw the M113 become ubiquitous. American mechanized infantry units operated throughout the country. The vehicles proved vulnerable to mines and rockets, but they still saved lives compared to walking. The Middle Eastern wars demonstrated the concept at scale. Israeli armored infantry fought in 1967, 1973, and subsequent conflicts. Their doctrine emphasized close cooperation between tanks and mechanized infantry. The success of Israeli armored operations validated the approach. Arab armies adopted similar methods. The Gulf War in 1991 showed modern mechanized warfare. American armored divisions with M2 Bradley fighting vehicles advanced hundreds of kilometers in days. The infantry inside the Bradleys could fight mounted or dismounted. They could engage enemy vehicles with missiles. They could suppress defensive positions with automatic cannons. The capability had evolved far beyond the improvised kangaroos, but the principle was identical. Iraq and Afghanistan presented different challenges. Urban warfare and counterinsurgency didn't always require armored carriers. But when they were needed, they were indispensable. Infantry needed protection from IEDs, from ambushes, from snipers. The vehicles evolved again. They added more armor. They incorporated better sensors. They integrated active protection systems. The requirements changed, but the fundamental need remained. Current developments continue the evolution. Infantry fighting vehicles are becoming more sophisticated. The German Puma, the British Ajax, the American M2A4 Bradley all represent incremental improvements on a concept established 80 years ago. Hybrid propulsion is being tested. Unmanned variants are being developed. Active protection systems are becoming standard. The technology advances, but the mission stays the same. Some modern armies are questioning whether traditional mechanized infantry is still relevant. Drones might replace some functions. Light infantry with advanced weapons might be more flexible. Urban warfare might not favor heavy vehicles. These are reasonable questions. But whenever conventional warfare is discussed, armored infantry remains central to planning. The assumption is still that infantry will fight from vehicles. The story is often told as a tale of innovation, of military genius finding solutions under pressure. That misses the point. This wasn't genius. This was desperation meeting available resources. Someone looked at the problem of infantry casualties and found a solution in the parking lot. The innovation was simple. The impact was enormous. The men who first climbed into converted Shermans didn't know they were changing military history. They knew the ride was uncomfortable and loud and hot. They knew it was better than walking. That was enough. The tactical revolution happened because soldiers wanted to survive, and someone gave them a way to do it. The credit usually goes to the commanders who authorized the conversions. They deserve recognition. But the pressure came from below. Tank crews who watched infantry die. Infantry officers who needed better options. Soldiers who were willing to try something uncomfortable if it kept them alive. The improvisation came from necessity, not inspiration. 80 years later, armies still don't send infantry across open ground on foot when armor is available. The lesson from Normandy became permanent. The improvisation became doctrine. The desperate solution became the standard. And thousands of soldiers over decades lived because someone in 1944 decided that tanks could carry more than crews. That's the story. Not a tale of genius, but of adaptation. Not a miracle weapon, but a simple idea applied when it mattered. The most dangerous part of an attack was the walk. Someone found a way to skip the walk. Everything else followed from that. The kangaroo vehicles themselves are mostly gone now. A few survive in museums. The Canadian War Museum has one. The Tank Museum in Bovington has another. They look crude compared to modern vehicles. The welding is rough. The accommodations are minimal. But they represent the moment when a fundamental problem finally found a solution. If you want to continue exploring the decisive moments and tactical innovations that shaped World War II, subscribe to World War II Impact. We bring you new documentaries every week, examining the decisions and adaptations that changed the course of history. Thanks for watching, and we'll see you in the next one. Don't miss out on our latest deep dives into Cold War espionage, secret operations, and newly declassified intelligence. Subscribe to Cold War Black Files and get notified when we release new content.